OHBM student and postdoc special interest group. And today we're very excited to welcome Dr. Russ Poldrack, who will be leading our first how-to workshop of the year on Better Code, Better Science. And Dr. Poldrack is the Albert Ray Lang Professor in the Department of Psychology and Director of the Stanford Center for Open and Reproducible Science. And his research uses neuroimaging to understand the brain system's underlying decision-making and executive functioning. His lab is also engaged in the development of neuroinformatic tools to help improve the reproducibility and transparency of neuroscience, including the Open Neuro and NeuroVault data sharing projects and the Cognitive Atlas ontology. And before we begin, just a quick note that this workshop is being recorded and will be shared online on our YouTube channel. We do request that while the project's going on or while the presentation's going on, that everyone remains muted. But if you have any questions at any point, feel free to drop them in the chat and we'll do our best to address them and bring them to Russ's attention. Aaron, our awesome chair of the OHBM Student Postdoc SIG, will be handling the questions portion. And with that, I will hand it over to Dr. Poldrack. Thank you so much again for being here. Everyone is really excited.
Awesome. Well, thanks for the invitation. I'm happy to be here. Okay, so let me just give a brief introduction, and then we'll jump right into it. So what I'm going to do here today kind of builds on what I've written in this book that I've done recently, which is available on GitHub. If you just Google "Better Code, Better Science," you'll be able to find it. And it's basically a book about building scientific software in the age of AI-assisted coding and trying to make the software as robust and reproducible as possible. So this is the table of contents. And you'll notice that, there's a chapter on coding with AI that kind of goes into a little bit of detail about using AI tools. It's not the first chapter. It's actually the fifth chapter. And importantly, it comes after the chapter on software testing. And that's because I think that using AI-assisted coding tools well for building scientific software really requires thinking about how you're going to validate the software. I mean, ultimately, we want to make software we can trust. And the question is, how do we know what we can trust? Well, we know what we can trust because, we can actually test it and make sure that it does what we think it should do, at least, as well as possible. It's never possible to completely test everything about a piece of code, but we can at least try to do as well as we can. So can we go ahead and paste the link to the GitHub repo in the chat? So what I'm going to do today is give just kind of an overview of using software testing in the context of building code with AI. And I'm going to use a pretty simple example. If you want to see any of the materials here, you can go to the GitHub repo that was just posted. And so this is the kind of the handout that lays out what we're going to do. It's pretty simple. What I want you to walk away with this knowing is, one, why we need to do tests. You're going to see, I hope, I'm doing this kind of live. Usually it works. So we'll see if it works this time. Understand the concept of test-driven development, and then understand why it is that we can't just let AI write all the tests for us. We have to actually understand the tests that it's writing. And so we're gonna use a pretty simple example that I think many people in the audience would have had some experience with, which is Cohen's d. This is a measure that we use to quantify the effect size of a particular statistic, right? And so it's just basically it's the standardized difference of two means. It's like the number of standard deviations that two means differ from one another. And that's a simple explanation, but there's actually a lot of different ways to define it or compute it, depending on the assumptions that one wants to make. Do you assume that there are equal variances? Do you require that the sample sizes are the same for the two for the two different samples? Do you want to deal with the fact that Cohen's d turns out to be biased for small samples, say 30 or less? These are all different ways that one can compute it that have been defined in the literature, which mostly come down to defining kind of the variance estimate, the standard deviation. Okay, so let's jump right into it. So this is what we're going to do first. We're gonna and if you have a chat bot open, you can follow along with me. we're, I'm going to give this prompt to an AI system. Write a Python function to compute Cohen's d for two independent groups. I'm not going to give it a lot of detail about what I want. We're just going to see what it does. So I'm going to use Claude Sonnet here. Let me just put in that. Oh no, that's not what I wanted. Um, let's see, can I copy this? Okay, there we go. Let's put that into Claude Sonnet and let's see what it does. It'll probably give us some code just like that. Okay. Um, so I'm going to copy that code. We're not going to even look at what it says about it. I'm going to copy that code and I'm going to go over here into my editor and I have an empty file here, cohensd.py. I'm just going to stick my function into that. And how do we know if it works? Well, let's look at it first. Okay, so it is going to um, takes in two things here, two what should be array-like. They could be a list, they could be a NumPy array, um, and it's going to just make sure that they're actually NumPy arrays. Each of these is just turning this into a NumPy array, and then it's going to compute the length of each of them. It's going to check and make sure that each group has at least two observations. That's good, right? Often it'll create code that doesn't actually check that. It's going to compute the mean, the difference of the means. Um, it's going to compute the pooled standard deviation. So that is, go back to that's this formula right here. The pooled Cohen's d. We'll look at the code and make sure that it actually did it right. It usually does. Um, so that would be where do we go? The square root of n minus one times the first variance plus the second n minus one times the second variance divided um, by all the n's minus two. And so you'll notice that the it said DDOF equals one right here. If you remember, when there's various ways to compute a variance, and the one that's more unbiased or has minimizes the bias actually doesn't use the total number of samples as the degrees of freedom. It uses n minus one. And that's because you kind of lost a degree of freedom when you computed the mean. And so we need to tell it, this DDOF says basically take one out of the total n when you compute the variance. Okay, so that's good. That's kind of what we want it to do. Um, and then it checks whether the standard deviation is zero. And if it does, it'll raise a value error. So these are both good, right? These are you usually want your code to kind of make sure that if there's like a bad situation, that it doesn't just let that go and kind of give you a garbage result. You want it to instead complain, and in Python, you want it to kind of raise an error, and a specific kind of error. So, if we'll say, if the sample size is less than two for each of these, that it's going to raise this error saying you need more than two observations. If the standard deviation is zero, which could happen, for example, if all the values, you have more than two values, but all the values or more than one value, they're all the same, that could give you a zero standard error. And that would ultimately cause, because you're returning then the mean difference divided by the pooled standard deviation. In fact, if you didn't do this and you just, if you removed this thing, then when it tried to do this, it would have a divide by zero error. So let's go back to our editor now. Actually, sorry, let's first see what other questions we want to ask here. So we said, which formula variant did it use? It used this first one here, the pooled variance Cohen's d. Did it use n or n minus one in the denominator? It used n minus one, which is generally what we'd want it to do. Did it apply Hedges correction for small samples? No, it didn't. It didn't offer us that. And then what happens with the edge cases? equal means, zero variance, n equals one. And it actually dealt with at least these two. Okay, so now let's figure out like how do we know if this test is correct? Like we've looked at it, or sorry, if this code is correct. We've looked at it. It seems kind of reasonable. Um, and but we'd like to make sure that we actually test it to make sure that it's kind of doing everything that it's supposed to do. And when you write tests, you want the test both to check that it does what it's supposed to do and that it doesn't do what it's not supposed to do. And so we're gonna sort of look at each of those types of outcomes. Um, and so the first thing that that if we were all in the same physical room, I would be talking to you about this and we would be kind of brainstorming it. That's a little harder on Zoom. But the first thing we want to do is think about like what are all of the types of, if we want to make sure that the code is doing what it's supposed to do, like what kind of things do we want to check, right? So we would want to check kind of normal inputs, right? We want to make sure that like when we give it something where we know the value that it gives us back the right value. We want to check various edge cases, things that are sort of unlikely but might happen and might cause things to go wrong. We want to check error conditions where we know things could go wrong, just to make sure that it doesn't give us back a value that's like nonsensical, but it does, basically when one of the philosophies that we have about software testing is we want things to fail in a loud way, right? We don't want things to like fail in a quiet way where we get a value back even though things went wrong. We want it to tell us things went wrong in the loudest way possible. In Python, that's raising an exception. So unless that exception gets handled somehow, it's going to cause the thing to crash. Um, okay, so let's actually just forge ahead and have it actually try to create some tests. So what I want to do is say, I'm going to give it this prompt: write a comprehensive PyTest test suite for the function called Cohen's underscore D that computes Cohen's D for two independent groups. That's the code we just wrote. The function takes two lists of numbers and returns a float. Include edge cases. So this is kind of assuming that my chatbot is going to be able to figure out what are the edge cases for computing Cohen's D. Fortunately, Claude's pretty smart. Um, okay, so I'm going to go back to my chatbot, and I'm going to say now, yeah, write my comprehend. PyTest is the testing framework that we use in Python, if you're not familiar with that. Um, okay, so let's have it do that, and it will very shortly spit back a bunch of stuff. Um, let's see, is it done? Oh, it's still going. Okay, let's let it finish. You can see it's giving us a bunch of things. All right, let's. I generally, so some of you, depending on your level of Python expertise, you may or may not have dealt with classes in Python. Um, I, you know, I would often tell Claude not to use classes for my test just because it makes things a little more complicated. But it can also, if you don't understand classes, but it can also make it a little bit easier to do things if you do understand them. So I'm just going to leave them there. So it's creating these different classes. Okay, it's all done. Let's copy that. So it actually tells us. So it's breaking these things into five different kind of types of tests, right? One is to test the core formula correctness. One is to test, kind of boundary valid sizes, like things that are legal, but kind of at the edges. Numerical edge cases. We'll come back to that in a bit. Different types of inputs, and then handling of different kind of error cases. All right, so let's go back to Visual Studio Code. I have an empty file here that I'm going to put all my tests into and save that. Um, so let's just kind of peek. Actually, let's go run the tests first. So I'm going to go into my, just zoom in a bit. I'm going to go into my terminal down here at the bottom. And if I just say PyTest, test Cohen's D, Okay. It failed, and it failed because it can't find the Cohen's d module. Why is that? Well, it's because it assumed that, so my file is called Cohen's d.py, and it assumed, it says from Cohen's underscore d.py. So let's fix that. And now go run the test again. Okay, so it's got let's see. Let me pi test minus v. I'm gonna have it be a little more verbose because I want to see what it skipped. Okay, so it passed. So pi test will basically go run each of these tests. So like this first test returns float. You see that's the first one listed here. It passed. What is it doing? It's basically checking whether when you give Cohen's d two lists of numbers, is instance basically checks whether this thing is a certain type, and here it's checking to make sure that the value that comes back is a floating point number. It's not a string or anything like that. So one of the things that we often do when we write tests is we use this assert statement. Assert basically just means make sure that whatever comes after this is true. If it's not true, then it raises an error. Um, so let me just quickly change this. So let's say that I was instead asserting that it was a string, um, and now I run it. Now it's going to give me an error, right? It'll say uh, where I asserted this thing as a string. Um, you know, it. I said that this floating point number should be a string, but really this floating point number is a floating point number. Um, so that's what would happen if that was wrong. Um, so let's look at some of the other tests. It's testing for a known effect, a known large effect. Gives it two sets of numbers, and then what does it do? It says, I'm going to assert that the value that's computed by that Cohen's d function is the same as the value that's computed by this expected d function. And expected d is up here. So what is it doing here? It's basically using exactly the same formula that it used the uh, in the main implementation in order to test the thing. Um, Now, one reason it's probably doing that, and actually one thing that I should have done here, you see that I did both of these in the same chat session, right? I started saying, write this thing to compute Cohen's d, and then I came down here and said, okay, now write a comprehensive test suite. But it knows how Cohen's d was computed in the previous cell because it's still in the context of the LLM. And so it basically is just reusing the same thing that it used above. Um, that's a problem because it might be wrong in both places, right? And the test would pass even though the math is wrong. So what I really should have done is go up here. Let's go do a new chat. And now I'm going to have it write a comprehensive test suite again. And let's see how it does it this time. We have to let it write all the stuff. Um, in general, like especially for writing tests, it's often useful to do things in separate, sort of separate chat sessions. And this also requires to make this effective. If you have memory turned on, like Claude lets you turn on memory so that it remembers things across your chat sessions, which can be useful kind of in regular life. But for this kind of stuff, you really don't want it to remember. So you could also go to a different chatbot. You could go to, Gemini or GPT-4 or whatever, and GPT-5 and find and have it create the tests. Um, just because you don't want it to carry over the math from its head in the previous one into what it does in the tests. Um, well, we'll okay. It's going to give me the file now. Okay, let me just copy all that, and I'm going to stick this into my tests. Just remove all of that. No. Um, Copied. Okay. Okay, let's run our test again and see if it actually, okay, it made the same mistake again here. Um, okay, so some of our things have failed now. And the question is like, why are they failing? What's going on here? And so they could be failing because the answer is wrong. They could be failing because the test is wrong, right? And so when AI writes the test, it's always up to you to actually go in and figure out, like, are the tests doing the right thing? And if they fail, why did they fail? So let's go find this first test that failed, which is test known value equal size groups. That's this one. Okay. So what's it doing here? It's setting up uh oh, it looks like it made a syntax error, did it? Um I guess that's okay. So it's basically setting, the mean to 4 and the variance to 5, but then it's like doing math and it's this, oh, sorry, that's a comment. Got it. Okay. So um it's basically saying, we know what the answer is here. The expected is zero point 0.5 divided by math square root of 5. How does it know that, right? It seems like it basically just kind of came up with some values, and it's saying that. So it seems like it thinks that the variance, the pooled variance should be 5, and the difference should be zero point 0.5. And that doesn't seem to be the case, right? It's the answer should be 0.217. Oh, sorry, no, the answer should be 0.22 according to this expected number. The number that it comes out with is this 0.217. And so something so that's this is a kind of a fail on Claude's part, right? Because it shouldn't be it sh you know it shouldn't be kind of just sticking, we call these magic numbers. It shouldn't be sticking magic numbers in the code and kind of pretending that things are working, or that the answer should come out this way when it doesn't. So what we would instead want to do is, create two data sets for this test known value equal size groups. What we would want to do is like create a set of numbers, and then basically make each of them. So let's see, we say G1 equals uh, G1 minus actually, what is let's see what the means, let's see what the actual means of these things are. We just go down here and bring up IPython and um, uh, okay, import. I'm just going to see what the mean is real quick. G1, P dot mean. Okay, so it looks like it got those right. So it looks like what it did wrong is this, right? Because and actually interesting, right? Okay, so these have group one and group two have different variances, right? And so it's assuming that the pooled variance is 5. Let me see if that's actually correct. Okay, see, it got the variance wrong here on that one, right? So it thinks that the variance is of these is 4 and 5 point is sorry, it thinks that they should be 4 and 6. They're actually 4 and 5.25. So it basically just screwed up in creating this test case. And fortunately, at least this is a screw up that we can, where we can see. So what we would need to do is let's see, we could either change these numbers. What I would really want to do is say, like, np.random.rand, make some random numbers. Let's say 10 of those. Is that going to give me 10 random numbers? I think. Yes. Okay. Um, G2 equals np number and sorry, let's do random normal numbers. And and da, 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 and make this have a mean of zero in p sorry g1 minus np dot mean g1, and then g2 will be the same, and we'll say g2 uh, minus mean of g2 plus 0.5, and then um, want to divide that by the standard deviation so that it's exactly 1 divided in p dot g1. I'm just creating some data here to make it probably work. Let's see. If this doesn't work immediately, I'm going to go move on. Okay. So we're going to take the mean of that, G1. That's a very small number. Yes. Okay. So now they differ by 0.5, and let me make sure that their variances are the same. That's okay. Good. So now we have data that have a standard deviation of 1, and they differ by 0.5. So now we can just the square root of 1 is 1, right? So the expected value should be 0.5. So we can just remove that. So now we've made sure that the answer should be right. I hope this works. Oh, I didn't. It doesn't know about what numpy as np. Okay, I did something wrong there. I'm gonna leave it to oh. Okay, I'm gonna leave that for now. Let's go look at another one. So basically, we would have to figure out what I did wrong in my math here, and okay, and fix that. So let's go and look at another one and see what happened here. So here, it's saying let's test if one or both groups have zero variance, then we want to basically make sure that we that we check for that we're checking for that outcome. Um, so test constant group zero variance. So what is it doing here? It's basically creating one of the groups here has zero variance, right? And it computes Cohen's d, and then it says assert that that it either is that something has gone badly here, right? That it's that either you have an infinite, like a divide by zero error, or that you get a not a number value. Um, and then it says except value error decision and zero division error, and then it's also okay for that to to uh, to happen, right? That's just another way that the errors could pop up. So we have to figure out why it's failing here. Let's go look and just for the purposes of time, I'm not going to try to do that now. I want to go look at what else it might have. I think yeah, I'm not sure why it's not working here, but it seems like it assert false or false. Um, uh, that's Interesting, right? So this is a weird thing where it's not giving back an infinite or an isnan. We could actually try it. Let's just see what's going on here. Why is this happening? Uh, get these imports in here, and then um, and so now we can run Cohen's d. What is the result? The result is a number that is neither of those, right? But the variance of G1 in P dot var G1, that should be zero, right? So it isn't actually properly catching this, and that's because the function, we go back and look at the function here, doesn't it doesn't actually check whether the individual things, whether the individual groups had zero variance. It only checks whether the total variance is non-zero. And so this is actually an interesting question. Do we care, like if this happens where one group has zero variance and the other doesn't, do we just put them together and pretend that one of them doesn't have zero variance? That seems like a bad idea. And so really we need to add in something like if np.var g1 uh, uh, and np.var g2, then we're going to raise a value error. Let's try that. We run our PyTests now. Oh, I didn't save. I don't have to save here, do I? That's still not working. So we'd have to figure out how to get that. I think we're going to just leave that for now. Let's go look at why the third one is failing here. Okay. Values near the float max should not produce infinite. So in one thing that often happens in testing is you have to deal with either very small numbers or very big numbers. And so, the system has a kind of the largest number that it knows about that's kind of that it doesn't treat as being infinite. It also has the smallest number that it knows about that it doesn't treat as being zero, the smallest, fraction that it doesn't treat as being zero. And so what this is doing is saying, let's make some really big numbers, like 1 to the 150th, but that's just one, isn't it? Uh, uh, get it uh, two. Okay. Um, huh. Okay. I'm baffled by this because I would think that if you exponentiate one, um, I don't know how that works. So let's make that a big number like 10e1, 10e80, 10e90. Okay. And if we now run our test again, okay, now that one is passing because it was something was wrong with that one E90 thing that it used. Okay, so now you've seen a few examples of how, even a very good model like Claude Sonnet 4.7 can get things wrong in the test that it writes for you. And so you really have to kind of dig in and look at the tests. Let me just stop there and see if there are any questions. Or feel free to put stuff in the chat as well. Okay, let's go back then. Uh, we had a bunch of test cases that we wanted to look for here. I know that it didn't do the hedges G, right? At least it doesn't tell us about the hedges G. So that's one thing that it didn't do. It looked for zero variance in one group. I'm pretty sure it looked for single observation. single element per group. Yeah. Uh, empty input. Yes, test empty group. Okay, so it actually got a lot of the stuff that we were hoping that it would get. Um, this one actually, remember the first one that we wrote using in the same chat session did this circular expected values thing, right? Where it basically it just took the math that it had put into the Cohen's d function and then kind of used that again in the test. So if it was wrong in both places, the test would still pass. Um, when we created the test the second time outside of it still kind of used the same math in its in its kind of comment here, but it didn't test things in the same way, right? It actually came up with it sort of did things by hand, and sometimes it did them wrong, as we saw here, where it kind of came up with incorrect numbers. But it didn't just reuse exactly the same math that it had, exactly the same kind of function that it had in the original code. Um, Another thing that you often see in AI generated tests is that the tests will be overly loose. So they'll often be kind of like, as long as the thing returns, as long as the function returns something that isn't none, it'll pass it, even if it's meant to be testing for something more stringent. And we saw, this actually, let's see, did it do that one here? Is it testing? Actually, it's not even, let's see if it's testing floating point input. It's not actually testing for output types here. Um, I don't think. Test input types. So it tests to make sure it can deal with different input types. Um, I'm not seeing any okay, constant value, single element, constant variance, test empty. Okay, so it makes sure that it'll behave properly with one or both of the groups is empty. So that's good. Um, but sometimes, often you'll see them like not testing things in the way that they should. And that's similar to this, is if it only runs what we call a smoke test. A smoke test is a test that basically just makes sure that the thing doesn't crash. So if you were to, we can add a smoke test here. Let's say def test smoke, and basically uh, to do this, all I want to say is assert Cohen's d is not none, right? That's basically just making sure that it gives me back, or actually, I wouldn't even necessarily do that, right? Because that is actually checking something about it. I might just uh, run Cohen's d and see if it crashes, right? So we can run that. The smoke test passes because the function works. But now if I were to go back to my function, say, and just put something kind of garbagey in there, just something that's going to cause it to crash, and now I run my test. Now everything breaks, but the smoke test breaks because it says, hey, wait, there's a thing in there that's not defined, but now all the tests break. So a smoke test is basically just making sure that the thing runs without crashing. Remove that. Well, I guess we can leave it. Let's remove that so that our function works. All right, back to this. You'll often get them creating sort of like multiple tests that look at the same code path with different data, so they're kind of redundant. You'll get them not testing for bad input. Here, it looks, just from that quick glance of scrolling through, it looks like it actually did a pretty good job of like testing for different types of input. And magic numbers, it actually did this, right, where you have expected value with no explanation of how they were derived. Or in our case, it kind of tried to, here where it was, oh, I've removed the thing now, but here it was trying to do this stuff, with sorry, here, right? It just had its numbers wrong, but it basically had put into expected a magic number. So in general, you want to know where the test values are actually coming from. Okay. So when we, so just kind of stepping back, what have we learned so far, right? AI tools are really good at generating tests, right? At generating tests that will run. they can often be really good at like finding all the things that you should be testing, but they have a tendency to really want the test to pass. And so one thing that you'll commonly see is like if there's a problem in the code, they'll write the test and especially if you're working like if you're working in Claude Code or in some things where the test and the code that's being tested are being written by the same tool in the same kind of session, it'll often work around the problems in the code in order to give you tests that pass because I think the models have been trained to like really want the test to pass. At least that's true for Claude. I haven't done enough with the other coding models to know kind of to what degree they also do that. But I've my impression is that they all kind of do that. So one of the things that a lot of people have moved towards is basically doing what we call test-driven development, which is before you ever write any code, you write a test that fails. Or sorry, you write a test that for the code that doesn't exist yet, that test is going to fail, and then you have the coding agent write code that can pass all the tests. So how might we do that here? Well, let's say that let's say that we're going to get rid of all the code in here, and we're just going to say pass, right? So all that's or just return none. Okay, so the code doesn't really do anything right now except just like take in some inputs and return nothing. And so if we were doing test-driven development, then what we'd want to do is basically create this, and then we'd want to create a bunch of tests. And actually, let's go back and kind of start over in Claude and see how well it can do. So let's start a new chat. New chat. Okay. Um, I have a I would like to perform TDD, and it usually will know what TDD means, test-driven development, for a function call that function to compute Cohen's D on two array-like items. Um, um, Please generate a test suite that will exercise all important aspects of this function, so which I will then use for TDD. And so now it's going to go and create a test suite for me. We will see what it looks like in comparison to this old one. Let's see, go back here. I just want to remove all of my tests here. And Claude is taking a moment. One thing I think what people are finding is that for especially if you're using like a coding agent like Claude Code or Cursor or one of these things, that having it do test-driven development of writing the test first and then creating the code to make the test pass um, ends up having the agents both create code more effectively and also it prevents them from creating code that you don't need. They often will tend to kind of we call it gold plate. They'll basically tend to kind of do more than they need to do. And if they're doing test-driven development, they know that all I want to do is make the test pass. As soon as all the tests pass, I'm done. So the tests need to check everything you want the code to do, right? In some way, the test becomes your specification for what you want the code to do, and then basically you just set the thing going to make the test pass. So let's put this in. Now I'm pasting in all my tests here, and it says, what's the signature supposed to look like? Let's fix that, change the module name. And so it's not actually doing the best. So it basically wrote a version of the pool standard deviation here. We have to trust that that's correct. And then it's going to create the expected D here. Um, and so we would, again, here, you need to make sure that the tests are actually correct. So we would want to check the math here of just at a glance, it looks correct to me. Um, but we would want to test that, for example, against another implementation, or just make sure that we've like looked closely at the math. So now it's going to, it's going to do all the things that it should do. Test values of small, medium, large. Um, you know, Again, if I was doing this to create software that I was going to use in my research, I would want to go through and check each of these tests to make sure that they're doing the right thing. There's a lot of tests, and so that could take a little bit of time. But let's now, in the last few minutes that we have, go back to Cohen's D, which is empty. I'm going to open up my let's see, we'll use Claude Sonnet again. I'm going to open up my little chat window here. Is in agent mode. Yes. So I use VS Code, which is a pretty nice editor for in general. It has a lot of features. And it has this nice embedded chat window that has an agent mode where you can just say, okay, uh, build the Cohen's D function using TDD to pass all the tests in test Cohen's D.py. Okay, and so it's going to inspect the tests. Um, and so it says the minimal green implementation. So there's this idea in the test-driven development pattern is referred to as red-green refactor. So the idea is that first the tests should all fail. You have to make sure that if the tests don't fail when the code is just empty like this, then the tests aren't very useful. So first, you make sure all the tests fail. Then you go in and create the code that's required to make all the tests pass. That's green. And then you might want to go back and refactor to make things, cleaner, more robust, or there might be additional features you want to add. But that's what red green refactor refers to. So it's going in and reading stuff. Why don't we, given that this is probably going to take a few minutes, why don't I stop here? We've got about 10 minutes left, and I have a hard stop at 11:30 my time. So why don't we why don't we open up to questions and sort of see what folks want to talk about?
Fantastic. Thank you so much, Russ. I wanted to welcome everyone to either put questions in the chat or just turn on your video and your microphone, and you can ask the question yourself. Can give a couple of seconds for anyone who has questions. Oh, look, we've got one already from Santiago. Perfect.
Okay, cool. So would you recommend Claude or other AI tools to develop large coding projects such as an app or a Python package? Yeah, so my workflow is generally that for small things, I'll often do it within like the VS Code chat right here. For any kind of larger project, for anything that involves multiple files, I'll generally use Claude Code because it's very good at one, it's very good at doing test-driven development and also good at like, kind of working across a larger code base. So I would definitely recommend using one of the agents like Claude Code, Codex, to do any kind of like larger like any kind of package or app.
Great. Amber?
Uh, Thank you. The talk is really useful. Like I haven't thought about actually building a test for my code. My question is like, if I am about to build a like relatively more complex code and with a lot of functions and there's some like logic step by step, how would you recommend to do this text?
Um, yeah, I mean, I think it, in general, the tools like Claude Code are so good now that that what I would generally suggest is first trying to use a coding agent and just work with it. So what they'll do, especially like for Claude Code, there's a thing called superpowers that you can install that will basically kind of interview you and try to figure out what you want. And you could often, like if you have written down a set of specifications in terms of what you want the code to do, you could also give it that as a starting point.
Okay.
And then what it'll do is kind of interview you, ask you a bunch of questions to try to figure out what exactly to do. And then it will come up with a plan. And then you can examine that plan and make sure that the plan has everything you want. And then once you're okay with the plan, you say go, and it will actually go and develop the software. So that's for anything beyond like a single, like a small piece of code. That would be the approach that I would suggest because I think it's just going to be more effective and more efficient. But then the thing that you need to do is make sure that you also go in then and look at the tests that it generates to make sure that they're actually testing the things that you want to be testing.
Thank you.
Mhm. Okay, so there's another question. Throughout your typical common analysis pipeline, which sort of tasks might you defer to human implementation or interpretation to feel more confident, such as choosing a measure, or statistical method, etc.? Yeah, I mean, for anything that's kind of like common, I feel like the current frontier chatbots are pretty good at answering like statistical questions. Like if you wanted to say, what version of Cohen's d should I use to compare to, uh, samples of numbers. I think that like, the chatbots are generally going to do a good job of telling you the answer to that. Um, I would say that for things that are less common, like things around fMRI data analysis, um, often, the models will not know enough kind of in detail. So I would say basically like if it's a domain where you feel like you have expertise, then you should probably be exercising your individual expertise to make choices. If you don't have the expertise, then a chatbot is a good place to start, but often you'd want to either kind of dig further into the literature to make sure that its recommendations are kind of on point, or talk to somebody that you know who has expertise around that particular thing just to kind of double check. Because I do find, that when I'm like using Claude to ask questions about stuff that I know about, usually it does a really good job, but occasionally it will get things wrong. Actually, not so much get things wrong. It will say things that are commonly believed in the field, but that like you or I might not necessarily agree with. Yeah, Steph.
Hey, I just wanted to say this was super helpful to see this test-driven development happen in practice. So first, thank you for walking us through all that. I had a specific question about sort of related to the last point about what we defer to humans. Um, and to me, it seems like, as we're using AI more for code development, it's harder for us to understand everything that's being written. And what
Yep.
I'm getting from today's demonstration is that it becomes increasingly important for us to really, really understand every piece of the test
Yep.
that's being written. And then a little bit less important for us to understand, or maybe we can't fully understand all of the original codes that we're testing. And I'm wondering for you in practice, for your workflow, do you end up like, to what extent do you end up feeling like you want to also really understand the original code that's being written? Like, do you rely very heavily on the tests and
Right.
then to an extent try to understand some of the original code, or
Yep.
start to just really, really rely heavily on understanding the tests really well?
Yeah. So yeah, I mean, one of the challenges is that the agents are so prolific that it just becomes like kind of, you know, impossible to have the time to read through all of the code, right? That you would like to. So I guess what my strategy has been is to primarily focus, the tests are kind of like our trust gate, right? We need that to be the place where we determine, can we trust the code? And so I first look at the tests and make sure that they really capture everything that I think is important to capture in terms of, failure modes, edge cases, stuff like that. Then what I would do is usually go and if I was going to go look at code, I would focus on the functions either where like I know that there are kind of tricky things that it's easy to get wrong, or like things that are really central. Like if you're doing a bunch of like, often a lot of the code is like kind of orchestration stuff and things like that. But let's say you have like, one function that defines like your specific algorithm that is like, central to what you're doing. Definitely you would want to examine that particular function and also make sure that it's that it's really being tested. And there are tools that I talk about in the book for like coverage testing that'll tell you like, which lines of the code are being covered by tests. And if there are any lines in that particular function that aren't being covered, you definitely want to like add tests to make sure that everything is being covered within that function.
Great. And we've got another question about whether you'd recommend using synthetic data to check the code.
Yep. Yes, definitely. I have a whole section in the book, the validation chapter, about using synthetic data. And it can be really useful. What are the challenges and things to keep in mind? I think that let's see what's important there. I mean, I think it's really about knowing like, what the important features are of the synthetic data to get the test right. And so you really have to know you really have to know kind of what the code is expecting, and then what are the kinds of edge cases that you want to test for, and then what should the data look like for those edge cases. There's another approach to testing that also kind of is sort of relevant to this called property-based testing. There's a tool called Hypothesis that basically just tries to throw a bunch of crap at your code and kind of see what might make it break. And so I would definitely suggest that and it actually uses some kind of like machine learning to figure out what types of data should I try throwing at the code to get it to break. And I have an example in the book of how I used that actually found an error that I hadn't actually found. So let me just, in the last minute I have, there's this thing about, are there any cases which you would recommend to code manually versus using an AI tool? In general, I think that, coding manually is great for learning. It's great for trying. I would at least probably have I would be coding in an IDE that will like do like I'm tabbing through right now, doing the kind of the tab complete stuff, because then at least does it at like kind of human time scale, right? And it often like once you start writing stuff, it will help fill things in, and you can kind of see how it works, and then do it the way that you want to do it if it's different. Because I think often the place where it's really nice is like places where it's kind of rote code where it's 20 lines of code and you know exactly what it needs to look like, but it's just a pain in the butt to have to like go type all those 20 lines in. You have them in your head. The translation from your head to the editor can take time. Often the coding agent's going to know exactly what it is, given the context, it's going to know exactly what it is that you want to do and is going to basically do it for you. So I should probably call it here.
Well, thank you so much, Russ. This was incredible. And I got a lot of chat messages privately just saying how helpful this was throughout the whole workshop. So thank you so much for your time. We really, really appreciate it. And for those of you who joined late, this will be on our YouTube channel within the upcoming week. So I will send an email out to those of you who had registered and you can get it there. So thank you so much, everyone, for coming and making this first how-to workshop of the year so great. So thank you again, Russ. We really, really appreciate it.
All right. Bye, everybody. Thanks.